Let's go ahead and take a look at notes 2-2. And if we look at our essential question here, it is asking us, how do you use inverse operations to solve equations with variables on both sides? So this is lesson 2.2 out of your book, and it is on page 92. So you can find where I'm at on page 92. Remember that this is already written in your book, so I don't expect you to write it down, but if there's anything that I highlight or underline, will you please make sure that you highlight or underline it as well? So we're going to go through some examples here, and these examples have equations with variables on both sides. I'm going to go through example 1 pretty quick because it's talking about solving equations with fractional coefficients. That means fractions as part of in front of our letter. Okay, the biggest thing that I want us to recognize here is the bar diagram. Okay, we can represent these with a bar diagram. And I also want us to remember what the equal sign means, and that it means the left side is equal to the right. That's going to be important when we look at the try it problem that I think you'll find a lot easier. So step 1, I have my steps. I went ahead and listed them down here, and thanks to Mrs. Silveri, I love the way that she wrote her step 4. Where it talks about combining the like terms, but we're only worried about the same side when we do that. We're only worried about the same side. So I added that there. And then I also like when we start to move on step 5, we're going to undo the add and subtract first. So let's just jump right in. I'm looking at the try it now 5 steps. These are the steps of importance. Great job solving. Page 92. What do you notice that I did to my try it? I don't like the boxes. Okay, I don't like them. I put a sticky note over them. You can write the problem out to the side if you don't have sticky notes. But I don't like the boxes. So we're going to walk through this when we're talking about class A. We have 2 different classes here. So class A was given a sunflower with a height of 8 centimeters, and it's growing at a rate of 3.5 centimeters per week. Okay, that per week is that W represented in our problem, number of weeks. So we're going to add that 3.5. So it's 3.5 centimeters per week, so times the number of weeks that this plant is growing, this sunflower, plus 8, because we started with a height of 8. It didn't start with a seed in the ground. It was 8 centimeters tall when we got it. Class B was given a sunflower, but it was a little taller. It was a height of 10 centimeters when they received it. And it grows at a rate of 3.25 centimeters per week. So grows a little slower, not much, but a little slower. After how many weeks will they be the exact same height? Remember right now at week 0 when they start this, one is 8 and one is 10 centimeters tall. That's not the same height. The reason we can set them equal is because we want to know at what time, at what week, will they be equal in height? So we're going to go ahead and we're going to walk through. I like the boxes to help you obviously set it up. That's why I left it for the first line. But I'm going to write this down here so I have a little bit more room. And we're going to go through solving this one. And we know that step 1 is to draw the line down the equal sign. Step 2 is change all subtraction to addition. I don't have any subtraction here to change. Step 3 is apply the distributive property. I don't even see parentheses. We do not have the distributive property. So we're moving on to step 4. Step 4 says combine like terms, but as Mrs. Silveri stressed, on the same side. So can I combine these terms right here on the same side? No, one doesn't have a W. Let's look at the other side. Can I combine my terms on this side? No, one doesn't have a W. So we can't even do step 4. So now we are going to move. and we are going to get our letters together first. So I always suggest as well, what is your smallest letter? Which one is smaller? Think of a 3.5. $3.50 or 3.25. Which is smaller? The 3.25. So let's go ahead and move my 3.25. The opposite of a positive 3.25 W is to take away 3.25 W. Whatever we do to one side, we do to the other. Please make sure you remember you're taking the entire term. The W is going with it. This becomes a big old 0. Remember, opposites are 0. That's why I circled it, meaning 0. It's gone. And on the right-hand side, we bring down that 10, we bring down our 8, and now, yes, these fractions, let's do this in our head, though. This is a simple fraction. $3.50 minus $3.25. We have a fourth of a dollar left. We have 1/4 left. W. Okay, now we want to undo our add and subtract. We have our W's together. We've combined our letters, and now we want to undo our add or subtract to isolate that W all by itself. The opposite of a +8 would be a take away 8. Whatever we do to one side, we do to the other. Why? Because opposites equal 0. Positive 8, negative 8 is 0. Bring down my 1/4 W, and 10 minus 8 is 2. And now we know that the inverse operation of 1 divided by 4, we can use our reciprocal here. Because it's a fraction, we can use our reciprocal. We're going to multiply both sides by 4 over 1. Why do we do that? Because this is going to become a big 1. 4 divided by 1 times 1 divided by 4, it cancels out and becomes just a plain old 1W. Multiply straight across, 2 times 4 is 8, and then 8 over 1. So at 8 weeks, these sunflowers in classroom A and classroom B will be the exact same height. So it will take 8 weeks. Remember, one started out taller than the other, but one's growing faster than the other. So at 8 weeks, they will be the same height. Let's go ahead and look at the next example. Here's a problem just going through the exact same thing, all the steps, solving, but with negative coefficients. Okay, so we're kind of talking about it. It looks like we're talking about a bank account here. Withdrawals means you're paying for something. It's coming out of your account. Deposit would be putting into your account. So you earn money and you put it in the bank to save it. Okay, and it's showing here, it looks like we're talking about Kelsey's bank account and Chris's bank account. And it looks like we want to find out at what week will they have the same amount of money in their bank account. So they set it equal and walked through the process. Let's walk through the try it. Yes, I did skip example 2. I apologize. I should have mentioned that. We're going to skip example 2. Let's walk through the try it now on the bottom of page 93. Now, there is not a whole lot of room there. What you can see is that I put a sticky note, and if it was me, I would write it on a sticky note, and you can place that sticky note next to the problem, or you can show all your work just in any empty space on the page. So here we go. Draw a line down the equal sign. Let's go ahead and change all of our subtraction to addition. So I have really a 96 plus a negative 4.5y plus a negative 3.2y. Sorry, I kind of went over my line there. Equals 5.6y plus 42.8, 0. I'll get things situated here back together so it's not over my line. Step 3, distributive property. I don't have the distributive property. There's no parentheses. Step 4, the way Mrs. Silveri had mentioned it. Do we have like terms on the same side? Is there anything over here we can combine? And the answer is yes. We can combine those y's. So that's what we're gonna do. We're gonna put those y's, combine them. So I have a negative 4.5y and a negative 3.2y, and that would get us a negative 7.7y. So we went ahead and combined those like terms. Do I have any like terms on the other side of my problem? No. So just bring it down. Just bring the problem down. Okay, now we are to step 5 and we need to move and isolate. We got to get those letters together. And I always say move the smaller one. Well, we know a negative is always going to be the smaller one. And so we're going to move this negative 7.7y. Take the y with it. The opposite would be a plus 7.7. Whatever you do to one side, we do to the other. This becomes a big old 0. So we are left with 96 equals, add those together, 13.3y plus 42.80. And now we really just need to isolate our letter. We got our letters together. We want to undo our add or subtraction here. We have add 42.8. The opposite of that would be a take away 42.8. And when we do that, we're left with 13.3y on the right-hand side, and I'm left with a 53.2 on the left-hand side. And now we are breaking apart my 13.3 times y. Let's put that dot in there. Now I'm breaking it apart. So I'm doing the inverse of multiply, which is divide. And whatever we divide by one side to get the letter by itself, we divide the other side by. This becomes 1y equals, and look at this, all these ugly decimals, and we get the whole number 4. That was kind of a long problem. They obviously gave you no room to write that problem, and so we need a sticky note or write on the side of our paper. So I've done 2 try-its with you. The very last slide I have would be the key concept box, which is on page 94. So I'm on page 94, and this is where your practice will start as well. And what I want us to notice is when 2 expressions represent equal quantities, we can set them equal. So this goes back to thinking about our example, or the first try it was about the sunflowers. We wanted to know at what week will they have equal heights. So we set those 2 sunflowers equal. We wanted to know on example 3 about the bank accounts. At what time or when will they have equal amount of money in their bank accounts? So we are setting equations equal here, and we are solving for them. That's all I have for you for lesson 2.2. It is more solving equations, and we have to go